Hello, everybody, and welcome back to another meetup of the OWASP Nova chapter. Thank you again, and I hope you all are doing well. Just a little really quick housekeeping. Our next meetup will be on August 20th, so please be on the lookout for more information about that. And if you have any questions during the talk, please feel free to just jump in the YouTube channel, post comments, and we'll try and get to them as we can. And without any further ado, here is Isaac Evans to talk to us about Semantic Grep.
Okay, well, thanks so much for that introduction, Ben. It's great to be here. Really excited to get a chance to talk through what we've been working on with Semantic Grep, or Semgrep, as we like to call it, which is an open source tool that you can get started with, actually, ideally while I'm giving this talk. So a little bit about me, just to get started. I'm Isaac. I'm one of the co-founders at a small startup named R2C. Prior to R2C, I was at MIT Lincoln Labs, and I spent some time actually near Northern Virginia working for the Defense Department. If you're familiar with the reverse engineering space at all, I used to work with the team that helped to build Ghidra. So that was a ton of fun and gave me a lot of early experience in program analysis when I was first getting started. And about R2C, the company I work at, we're a startup in San Francisco, building a business around open source next generation static analysis tooling. But I will start by giving you the too long didn't watch for this talk, which is basically that writing secure, robust, high quality code is really hard. There are static analysis tools that are out there, but they tend to be pretty noisy, pretty slow. And then there are other things that you might not think of as a traditional static analysis tool like grep. But grep doesn't tend to be expressive enough for the sorts of things that you might want to find inside a code base, which can be quite complex. So if you're looking for something that is fast, still code aware, flexible, and open source, this is where Semgrep comes in. It is a fast and syntax aware semantic code pattern search for many languages, kind of like grep, but for code. If you didn't understand exactly what semantic means, don't worry, we'll define that. And what is this useful for? It's useful, first off, and I mean, this is an OWASP meetup, so most of our focus is going to be on finding security bugs. It's also useful, and this is kind of a superset of security bugs, for codifying organization-specific domain knowledge. So enforcing specific patterns and best practices, upgrading from deprecated APIs, as well as just kind of getting a general sense of visibility into the code and how it's changing over time. So the outline of this talk is we're going to start by discussing grep and abstract syntax trees, or ASTs. And then Semgrep actually doesn't have a whole lot of syntax. The queries that we're going to be writing mainly look like the source code you already know how to write, so we can learn it in about 5 minutes. After that, we'll talk about if you're like, oh man, this thing looks so cool, it's got all these patterns. I'm lazy, what are the patterns other people have written? There are plenty of those, and they live in the registry. And then we'll end by talking about some of the advanced features that Semgrep has. So to get started, let's talk about why do we need this tool in the first place. So, we're all here at an OWASP meetup because fundamentally it's kind of hard to write secure code. Here's an example from a Python web framework where it's the documentation about how you set the cookie. And there are these 3 parameters, secure, HTTP only, same site, that if you ask any security person who works in web dev, they're like, oh yes, the values for these parameters should be the opposite of what the defaults are set in this web framework, right? Secure should be true, HTTP only should be true, same site should be at least lax, definitely not none. But if you're a developer, writing your code and you see something like this, so this is a little snippet of what code might look like in that Flask application. How can you get some automatic signal that, oh, hey, this is something that we should change? Like I haven't done the secure thing here, because the framework documentation certainly isn't going to tell you that. So the first thing you might think is, oh, we could use grep to find that. And so we might come in and write a regex query that looks kind of like this, response.setCookie. In this example, we're not going to be finding any of the instances where the flags are set wrong, like secure equals false, but at least we see all the locations where somebody is manually setting a cookie inside the application. So we can use grep for that, but we're going to have a couple problems. So we'll find like an example like the top one. It's not obvious to us, hey, what are the default arguments here? And should we be triggering on this or not? What if there's some change to the defaults and like secure is actually true by default? If the user comes in and they rename the function, so they import it as something else, an import alias. We're not going to detect that with the regex. The keyword arguments we're not going to be able to match on. So if they are correctly using the flag, like imagine they have set secure equals true, we're still going to trigger on that. And then of course, if it's like multi-line and there's like weird white spacing inside it, we're going to have to modify our grep query to find those sorts of things as well. And we're also going to trigger on commented out code. We might trigger on things that we don't mean to because they have a prefix match, like this controller underscore. So, with a relatively simple example of what we'd like to find and a relatively simple grep expression, we haven't done super great. If you tally it up, we've got 1 true positive, 3 false positives, and 2 false negatives. So, if you're familiar with this sort of problem and you've thought about static analysis at all, you might think that there's a relevant XKCD here. We had 99 problems, we used regular expressions. Now we have 100 problems. And fundamentally, what's going on here? The problem is that code is really not designed to be interpreted as a string. In fact, it is a tree. And the first thing that most compilers or interpreters will do when they parse code is they'll lift it into a tree-like representation. So there's some sort of pseudocode for that on the screen here. But that tree in compiler terminology is typically called the abstract syntax tree. And there are a lot of tools that have been written to do tree matching. So you might have heard of some of these, or used them in your AppSec career, like Bandit, dlint for Python, ESLint, Flake8, GoLint, GoSec, PyLint, RivoCop, TSLint. There's tons of these tools. And so we could solve our problem by just writing a checker inside one of those tools. That would probably solve the problem. There are a few downsides to this. One of them is that we have to learn how the tree structure looks like, what the AST syntax is for every language. So we could learn it for Python, we could learn it for Go. In fact, like not all of these tools, even though they're looking at the same language, they might use different AST syntax. So you have to have a lot of expertise in that. And then also you need language expertise to cover all the idioms. So you might know Python really well, but if your team, somebody on your team is writing Ruby, maybe you know the couple ways there are to call a function inside Python. But if there are like 4 ways to call a function inside Ruby, you have to be an expert in Ruby enough to be able to say, yeah, we've covered all the possible ways that there are to do this. So this is why typically people reach for commercial static analysis tools, but those have a couple of downsides. They're fairly complex, they're fairly slow, and they tend to be pretty expensive. And on the right-hand side of the screen here, I've got an example of a rule that's looking for calls to eval in JavaScript inside ESLint. So it's about 307 lines of code. It does a lot, it does a great job, but that's a lot of code to write for something that we would hope could be expressed as a fairly simple check. And this is where Semgrep comes in. So if we look at, like what options do we have for static analysis? This graphic comes from an article published by Instagram. On the right-hand side, you've got things that are really powerful, but very complex. So whole program analysis. On the left-hand side, you have things that are kind of regex-based. And on the middle, you've got your AST-based lints. And what Semgrep tries to do is actually grab the best of both worlds from the right-hand side and the left-hand side of this. So give you the convenience of regex, along with some of the more powerful features from a much more complex program analysis tool. So this is our goal for Semgrep to kind of be in the middle. And this is Semgrep. It lives on GitHub. If you go to semgrep.dev, you can find it straight away. Just by way of background, the first version of Semgrep was actually written at Facebook in 2009. Facebook used it a ton internally. And the original author, who was one of the early program analysis folks at Facebook, joined R2C last year. So Johan was one of the first people at Facebook to work on static analysis and also did his PhD at NRIA working on a project named Coccinelle. If you're familiar with that, you'll know that it is a tool that has created many thousands of patches for the Linux kernel automatically. Really cool project, and actually a lot of the syntax that you're going to see and pretty much any of the design choices that I can't take credit for because they're so good come from Johan or come from Coccinelle. So by way of language support, these are the languages that are currently supported in Semgrep. Ruby and OCaml are in beta. TypeScript and PHP are our next 2 priorities. And Semgrep is LGPL licensed, so you can use it for commercial stuff. We've also designed it so that it can run totally offline. It's not going to ship your code anywhere. It's pretty easy to get started with. So without further ado, let's see what it actually looks like to find some interesting things inside Semgrep. The first thing we're going to look at is just a really basic function call. So we already saw some of the snippet of source code for that ESLint check that was looking for eval. Closely related is exec. Both of these functions, they take a string, potentially from the user, potentially a hard-coded thing or whatever, and they turn it into executable code. So to show you what this looks like, I'm going to switch into the live editor. And the live editor lives at semgrep.live. You can actually follow along or even beat me to the punch by just going to this little snippet URL up here that I clicked on. And it's just got a little box where I can put the pattern here, and then I can put the code down here. And everything that I'm going to show you on the live editor, you can also run locally. So if you click this little ... and say run locally, if you have a local install of Semgrep, you can just run it, passing this config, and you can download the config file. It's basically just serving what's in the pattern box, or you can run it with Docker. Cool. So what we see here is we've got a couple different snippets. You can see this is kind of like, all right, like if we were grepping for exec, it would be annoying to consider the context of, is it commented, or is it inside a string literal, things like that. With Semgrep, we can basically just come in and copy and paste the code from here right into the pattern box. So if I put that in and I run it, we trigger on line 5 straight away. So that's pretty cool. You know, even if we change the content of the code, we like add some weird white space, it's still going to match just fine because this isn't grep. It's actually aware of the code structure. So the next question is, all right, what if I just don't care about it being named foo? I want to match any of these 4 instances, no matter what the variable inside is. And so the good news is there are only 2 changes to the source code syntax that you need to learn about, and I'm going to teach you both of them in about 5 minutes. The first one is a ... operator. So ... is just going to match a sequence of 0 or more arguments, statements, what have you. So in this case, we're going to match 0 or more arguments to this exec function. And when I put that in there, boom, now we're matching these 4 examples. We're not matching the commented code. We're not matching the code that's in strings. Even if exec was called without any arguments, we should still match it just fine. So cool, this ... operator, basically think of it as capturing a list or a sequence of things. That was pretty easy. Now let's go back to our example with the cookie problem and look at how we might solve this using Semgrep. So for this, we're going to switch to, like in the prior example, we were using just a single pattern. And I'm going to start by writing just a single pattern. So I've got one loaded up here, flask.response.setCookie. If you're not familiar with Python, I'm saying from Flask import response as R, so I'm renaming it, and I'm saying r.setCookie. So if I run this, should get some matches on the right-hand side here, and we can see that, yep, everywhere where there's a setCookie call, we're successfully flagging. We're not flagging on this commented out code. If somebody has a like setCookie, which is a different function than the one that comes from Flask, we're not going to trigger on it. So that's great. And now the question is, okay, in order to actually make this something that's useful to me as a security person to send to developers, I need actually a little bit more complexity, right? Like I don't actually want to trigger on any call to setCookie. I just want to trigger on the ones where they don't have the secure flag or the HTTP only flag. So for that, we've got a little YAML syntax that lets us actually combine things. And we can create an ID for the rule. We can give it a message that will be displayed to the user. So let's say, hey, please securely set your cookies. See example for more details. Great. And then I can mix 2 patterns together with Boolean operators. So my first pattern is just going to be the one that we had before. So I'm going to say flask.response.setCookie. Don't care about what the arguments are. But then I'm going to filter out the case where the cookie is being set properly. So for that, I'm going to grab this setCookie call from down here. I'm just going to do the secure flag and the HTTP only flag to keep it a little bit simpler. And so then I'll fully qualify this. So it's not just any setCookie, it's flask.response.setCookie. And if you've been following along, now we've got a little bit of a problem here that, well, there are some arguments that come before, there may be some arguments that could come after. We don't care about those. And so I'll just use that ... operator to say, yep, don't care about however many arguments come before or after. This is just the pattern that I want to take out of the possible matched output. So if I run this and I've done it right, we're now triggering on lines 8 and lines 13. which are the ones that don't have the secure flag set. So one question that you might have if you've been paying close attention is that in the code example, I've got secure equals true, HTTP only equals true. And in my snippet, I've got secure equals true, HTTP only equals true. But what if the order of these was backwards? So what if I changed my code snippet so that secure came second and HTTP only came first? Would Semgrep still match with this query even though the order of those keyword arguments are different? And if, in case you're not familiar with Python, the order of keyword arguments doesn't matter in Python. So these are the same sort of thing. They're expressing the same thing. They're functionally equivalent, or what we would call semantically equivalent. And in fact, when I do this, we're still going to successfully filter out line 26, because Semgrep is smart enough to know that, hey, this is Python. These are keyword arguments. The order of the keyword arguments doesn't matter. I'm going to stop to check and see if there are any questions. So feel free to ask questions in the chat. I've got it up on another screen. And I will take a quick drink of water before we go back to things. Super. All right, so that was our cookie problem, solved pretty fast with Semgrep, which is great. Let's look at something else in a completely different language. So just to show you that Semgrep can support, not just Python, but also Golang, here's a snippet example in Go. And what we're looking for here is that this person is creating a Go web server, and they're saying, hey, like serve on port 80. Maybe for our application, we'd actually really prefer that they listen and serve TLS, which is a separate function in Go, which is actually going to be using HTTPS rather than just vanilla HTTP. So we just like to trigger on, hey, anytime somebody is calling HTTP listen and serve, let's make sure that they get a little message. So again, I'm just going to copy the code here. I'm going to paste it into the pattern box. If I run it like this, that's going to trigger just fine. But of course, if they've got a different string here, it's not going to trigger. So again, using that ellipsis operator, the ... we'll just use that to say, yep, any arguments to this listen and serve function, we're going to trigger on. We're going to come back to this example, actually, because Semgrep is capable of making an autofix, which will actually forward patch this code to use the secure version, which is awesome. If you've ever had to interact with any static analysis tool, one of the common complaints is that, the tools complain about all these problems, but they don't offer any solutions. And, who would like to be around a person who constantly complains and never has a suggestion? Semgrep's capable of making some really cool suggestions. So we'll come back to that. But now let's look at one more thing. So I told you that there were 2 bits of syntax that you had to learn. The first one was ... The second one is an uppercase $. So this is what we call a metavariable. And it allows you to match a specific argument or identifier in the code. So in this case, we'll say, like $x equals $x. And I'm reusing, we call them metavariables. I'm reusing the metavariable, and an equality constraint is automatically going to be applied on the metavariables. So if I change foo to be foo2, this is not going to match anymore. If I change this to say print x, it's going to match both of these things right here because I haven't reused that metavariable. So we're going to come back to this concept a couple times, because being able to use, rather than just saying ... I don't care what goes here, being able to use the metavariables allows you to, kind of like a capturing group in a regular expression, grab and then reuse something for later. In fact, you can actually use the metavariables in the messages that we print out. So we can print out to the developer, like if we're using this, when we go back to that message field, if we put a $x, it will replace it with foo. So we'll come back to that in a second. I see there was a question in the chat about, hey, can you, how do you run all this locally? In fact, everything here you can run totally locally and offline. So if you just click the triple drop down and say run locally, this will give you instructions for a local install. And then you can use a remote URL as the config or a local file just fine. And that's just going to serve up whatever's in the pattern box here. Great. So that was kind of cool. In fact, we've actually used this to find bugs inside large code bases. And I'll show you an example of some from libapache later on in the presentation. So far we've kind of played with toy examples, things that are pretty basic. Let's go look at something that is much more like the kind of security rule that you might think about writing as an AppSec person. So here we've got a fairly basic kind of injection attack. This is a Flask application, which is just a little micro web framework for Python. The file name argument comes from the user. And then you can see this poor programmer, they don't know this is bad. They're just sending that file straight back to the user without doing any validation of the file name. So anything from the web server is automatically going to be we're serving essentially any arbitrary file, right? Like this is path traversal at least. So how would we detect this in Semgrep? Well, again, we'll start by kind of copying the code and pasting it here. So far, we don't care actually about what comes before this return statement. So we can actually use that ... operator to say, yep, any number of lines that come before this. I don't care what they are. And then we're going to come through, and we don't want any function named send file. We actually want flask.send file. And let's see. So this looks pretty good. Let's see if it matches. Yep, that matches. That's great. But we're still using file name, and really we don't care what this variable is called. So let's just put $fname here and see if that matches. Yep, so that matches just fine. Now let's see if we change this one to be file name 2, so not the thing that came from the user, we're not getting a match. All right, so that seems pretty good. We're now getting more to what we'd expect out of like a security tool. And what's kind of cool is that, in just less than a minute, really, we've created a fairly basic but real check for finding, like a legitimate security issue. And this is where, Semgrep really shines. So obviously, like there's a check there's a registry that we're going to talk about later, where there's like hundreds of checks that other people have written, designed to find common patterns. But really, the thing that Semgrep, at least as far as I can tell, is unparalleled in is if you've got some pattern in your code base that is like really specific to your company or to your project or to your framework, you can really quickly write a rule that is super domain specific. You might have something that like no company is ever going to publish a rule for the specific thing that you found, but it's really easy for you to zoom in and dial into it. Cool, so let's look at one last example that doesn't come from the security world and is a little bit more complex. Here's an example of something that is more of a business transaction type thing. So we've got basically a financial trading application, and what we're supposed to do is we're supposed to call this like verify transaction before we call make transaction. So fairly basic. You can see in here, I've got an ID, I've got a message, and then I've got pattern and pattern not here. So pattern looks like this. You can see I'm using, this example is actually in Java. So I'm using metavariables to capture the return type and the method. Then I'm using those ... to say, okay, whatever comes before or after this make transaction call, don't care. So I'm going to capture the pattern where any function that has a make transaction inside it. And then I'm going to filter out anything that has verify transaction before make transaction. So when we run this, we find that there are a couple instances, line 16, yep, make transaction by itself, that's bad. This one has make transaction and then verify transaction, so that's also bad. This one has some stuff in between them, but it's still doing make transaction and then verify transaction, so that's bad also. Okay, so now is the time to apply some of the things that we were talking about before. Here's an example where we're calling verify transaction and then make transaction, but we're calling them with different transactions inside them. So these are not the same identifiers. So if you've been thinking about it, you ought to be able to propose a solution that combines the ... with the metavariable things to fix this problem. So I'll give you a second to think about it while I take a sip of water. Cool. This is not rocket science, but what you're just going to do is come in and say, okay, like in the case that I'm filtering out, I only want to filter it out if verify transaction and make transaction have the same arguments. So I'm just going to use the $ uppercase letter, and I'm going to say, yep, okay, only if those two have the same. Now when we run this, boom, line 53 shows up, and our rule is succeeding. So that's pretty cool. Let's jump back to the presentation. And so this has been by example. I'm going to switch now. We've done a couple different examples. And now we're going to say, let's just do a recap of all of the syntax that's in Semgrep. So recap, learn all Semgrep features in 5 minutes. The first thing you get for free. So the first thing is code equivalence. So, like we saw a bunch of examples of this, the keyword arguments, the import aliasing, all sorts of stuff around that. And here's a really powerful example of that. So this is Semgrep using some constant propagation. Here we've got a call to Bento3, which is an AWS library. We're looking for hard-coded strings that are passed into that library. And if you look at lines 4 and lines 5, we're defining these strings earlier in the application, and then we're using them on lines 10 and 11. But Semgrep understands that, oh, some const here is actually just a hard-coded string. So our hard-coded string check still fires on line 8, even though the string is not an immediate. So that's pretty cool. And the nice thing is you get this for free. So even though Semgrep supports a lot of languages, it's not truly language agnostic. It has equivalences that are language specific for each of the sorts of languages. So the next thing is the ... operator. We saw that it can match arguments, parameters, characters, and statements. So here's a couple examples of what that looks like. And then the last thing was the metavariables. So the metavariables start with a $, and they contain uppercase ASCII characters. And then they match, you can use them to match all sorts of things, expressions, statements, names, etc. You can even do really crazy stuff where you match like whole lists of statements. So like in this example, the second one, we say if some expression, $s, else $s, that will actually match the full group of statements here where both the true and the false blocks of this if else statement are identical, which is super nifty. Cool, so that was the intro to Semgrep. It's been about, I don't know, 25 minutes, but pretty fast. Any questions? Let me go over and check the YouTube chat. I'm having some trouble with the...
I apologize, I was on mute. One of the questions that was asked is how does this contrast with GitHub's CodeQL?
Yeah, that's a great question. So CodeQL is awesome. I've played around with it a little bit as well. It's interesting. I would say that CodeQL is kind of more optimized for a security researcher. So if you are, you've got a lot of time, you're looking at a giant code base, you want to find a variant of a very specific bug class, CodeQL makes a ton of sense. Of course, it's not open source, so you would need a license for it. And then Semgrep is more optimized for the security engineer. So if you're like, hey, we're looking for, kind of the 80-20, how can we really quickly write some stuff that's actually going to give us some good signal that's specific to us? Semgrep makes more sense, but CodeQL is an awesome tool as well.
And then there's a specific instance. I don't know if you wanted to handle it. It's split up into kind of two questions, but it's how it's for a specific Semgrep scenario. So I don't know if you want to handle that offline or at the end of it. If you scroll up just a little bit in the comments.
Oh yeah, okay, I see that now. So to this question, the question is about can you use if you've got response that set cookie with the secure equals true, if a parameter flows in from somewhere else, like I call foo false, and then inside foo, I've got that as a variable, will it still detect it? Mm-hmm. The answer is not yet. So from a technical perspective, Semgrep is still intra-procedural. So we're working on expanding the support of data flow inside the Semgrep language. On the other hand, one of the advantages that Semgrep has is that because it doesn't do a true interprocedural, it's not doing the whole program analysis, it tends to be quite fast. So we see performance around 100,000 lines of code per second, which is not quite as fast as grep, but pretty decent.
And then looks like you have just two more coming in.
Yeah, there's a similar question about, for the example with make then verify transaction, would Semgrep define the case, detect a case where verify is called within a function that is, or verify is called within a function that's called prior to the make transaction? So it would not currently. There's actually the kind of interesting thing that Semgrep is built on top of this program analysis library, which you can use to do that. So Semgrep itself is actually kind of a small program. It's really just a front end to this larger program analysis library. So we're working on exposing more of those things. I've actually done a demo. You're not the first person who's asked that question, but I've hacked together a demo of doing this properly for other people. Of course, it's a little bit slower when you start doing that. And then Pingning asked if the library is available. I'll cover that under part 4 of the presentation, which touches on the more advanced features.
Cool.
Yeah, well, thanks for the questions, guys. Those are great. So, all right, this is the part of the presentation where if you've been like, oh man, that looks so cool, but what do you got for me right now? I don't have time to write these rules. You're in the right place. So you can either brew or pip install Semgrep, and then you can run it with a --config. That config is just a folder of YAML files or a remote URL. So we have such a remote URL, semgrep.live/registry is just a pretty front end for a GitHub repository that has a bunch of Semgrep rules. So we've written a ton of rules, the community's written a ton of rules. There are actually some notable security tools that you might have heard of. Node.js Scan, the latest version, is actually powered by Semgrep. So that's the thing that I believe it got integrated as the Node.js scanner into GitLab, which is pretty cool. And then dlint, which is kind of like a modern version of Bandit for Python from Duo Security. The dlint author ported his rules to Semgrep. Full disclosure, we actually recently hired him. So he works at R2C. And then we've had rule ideas contributed by the co-creator of Django and Flask, which are Python web frameworks, people from the Golang community, as well as independent security researchers from places like HackerOne. So just to give you a quick sense of what this looks like, here's the registry. You can kind of look through all of the rules and filter down by various language, category, severity, etc. And for each of these rules, you'll have like the pattern, any references, a message. Here's a little graphic that shows you, right now what we have as the community contributed coverage for OWASP Top 10. We've actually been talking with some OWASP people about making an official OWASP Semgrep rules repository. So watch for that. And if you're interested, we have a community Slack that you are welcome to join. It's linked from the GitHub and from semgrep.live, where we're talking about the strategy for what rules we'll write next. One thing that I wanted to share is that so R2C is a company. We have some services behind the scenes that essentially allow you to do large-scale map reduce on our platform, and we use that platform to tune the rules that get published to the registry. So you don't have to use the platform to benefit from it. So here's an example of the like $x == $x. After a few rounds of iteration, this is what the final rule for that looks like when you're like, well, yeah, I mean, technically this is like a bug if you're doing it inside your assert statement, maybe, but it's not something that a developer would care about. So with this in mind, we managed to find some fun real bugs. Oops, I missed my link. So here's an example. This is actually still present inside an Apache project. So I promised I would show it earlier. So the $x == $x is finding this example here. I'll give you just a second to look at it and see if you can spot the bug. And so the bug here is that the programmer meant to use node_ID, but instead used node.id twice. So this is always going to return true, and then they're always just going to return the first node. This is in a driver that doesn't appear to be used that often inside libcloud because we keep using it as an example and it hasn't been fixed yet. So we really need to go and report it. And then one other thing that's kind of cool is not only can you scale up across like tons of open source repos, you can actually go back in time on historical projects. So I mentioned dlint earlier. Here is an example of us running over the history of another Apache project using a dlint rule that's just looking for eval. So this is the entire rule right here. And now, hopefully you have seen enough of Semgrep to be able to interpret this. So this is looking for eval with a non-constant string because we're filtering out the ones that have string constants. And if you look at this over time, since the project started, actually, there were 2 instances of this eval. And then on the 14th of June, 2016, there was a commit where they were like, maybe don't eval user input. This is a problem. But you notice that it went from 2 to 1. Actually, much later in the project, they realized that they left another instance of eval in it. So we use like these sort of techniques to kind of validate, hey, we wrote this Semgrep pattern. Is it actually any good? When we run it on the history of projects, does it find edges that actually have interesting security commits? And really, the ultimate question here is this the sort of thing that a developer would be interested in fixing? For us, that's kind of the ultimate source of truth. Rather than like, did you think that it was an interesting security problem? If it really was, it should be something that you'd actually want to fix. So in terms of integrations, I see there's a question in the chat about like, hey, can it handle segments for committed changes only, not the full program? This is actually one of the strengths of Semgrep. So I mentioned earlier that this is just running on a per file basis. So obviously that weakens some of the strength of the program analysis, right? It can't, if you've called that verify transaction in another file before you made it to this file. Won't be able to detect that, but it does mean it's really fast and it's really easy to add to CI. So we have integrations for a whole bunch of CI providers, and these integrations take care of automatically figuring out like, oh, like, you know, only analyze the files that are involved in the diff, and they have a bunch of clever logic to not only analyze just the files that are involved in the diff, but only report on things that are new from commit A to commit B, so you don't run into an obnoxious problem where it's like, well, you shifted a file down by one line and all of a sudden all these findings came back. That's not great. So we already talked about the language support, but you know, here it is again in case you missed the start of the presentation. And with that, it's time to get into the really fun stuff, which is the advanced features. So earlier there was a question about how configurable and scriptable is Semgrep. So we've got a ton of documentation on semgrep.dev on the GitHub repository for the full configuration syntax. You can install Semgrep via pip as a Python library. So this is actually the latest version of Node.js Scan is doing exactly that. And then the core of Semgrep is actually written in OCaml. So all of the heavy program analysis stuff is written in OCaml. Most program analysis tools that come out of Facebook are written in OCaml. And we have a lot of expertise for that on the team. But if you don't know OCaml, you can actually still get involved with Semgrep because the shell of Semgrep is written in Python. So the YAML syntax, all of the output formatting, a whole bunch of the other kind of operational details are all written in Python. And this makes it actually really easy to kind of like get started with and you know, be friendly with. So the first advanced feature that I want to talk about is user-defined equivalences. So the whole idea here is like, okay, let's imagine we wrote a rule like, you know, x equals y, like this, and we specified that, you know, y was a string. Whoops, I didn't mean to clear that out. It would be nice if we could say, hey, there's actually an equivalence where I don't want to have to write the opposite of this. So I don't want to have to write, you know, string x equals y, like that. And the equivalence up here on this line lets us do that automatically. So it basically says, hey, anytime you see x equals y, that's equivalent to y equals x. So you can use this to, we use this actually in the engine. You know, I was talking about equivalences earlier, like for the keyword arguments and things like that. This is exposing to the author of the rule the same sort of capability that the engine has internally to be able to say, yeah, these two cases are actually equivalent. It doesn't matter. So that's a new feature, but one that we're really excited about. Another one, which you just saw an example of, but it bears doing in an isolation, is typing. So this is something that's super new in the engine, but you can actually use the same syntax that you would use to specify types in the native language inside the pattern that you're specifying. So that's really cool. In this example, you can see A is a string, B is an int, and so we're only triggering on the first case here and not the case on line 5. So the typing support is new. It's a little bit experimental, but it works pretty well, certainly for the basic types, and the you know, type coverage is always improving. One of the things that is going on behind the scenes is that we're working on using a tool from GitHub called TreeSitter to add support for a whole bunch of languages at once. So TreeSitter is a generic parsing framework. We've used things like that to get really cheap support for things like JSON. So if you've been thinking about this being like, oh man, like, yeah, oh, stuff inside code is scary, but you should see what people check into configs. Here's an example of using Semgrep actually as a query on an AWS IAM config. And so the same sorts of things you can see are being used. We've just got this ... operator looking for a specific resource type deep inside this JSON file. You know, so obviously there are things like JQ that you can use to like extract fields and whatnot. This is certainly not a replacement for that, but there are certain cases where it can be really interesting and useful to be able to have much more complex queries going on and like constraints across various things inside the JSON file. The next feature is kind of trippy, but you know, I've spent all this time talking about how grep is such a problem and like don't use grep, but you can actually combine grep and Semgrep. So here's a fun example where, coming back to that Bento 3 library for interacting with AWS, I've got this pattern here, and I basically want to say, yeah, okay, we're going to match like host equals some constant string. But now I actually care about what's inside this constant string. I don't just want it to be any string. I want it to be a string that matches a particular regex. So here I can actually use the pattern regex key to say, oh, here's a regex. So now we're only going to match if host is equal to this and not if host is equal to some non-local or internal IP address string. So that's pretty cool. If you're confused about how this is working, there's actually a debugger that will show you exactly what the various patterns are matching and how the filtration works to produce the final output, which is a little bit more of a power user feature, but people have found really cool. And then another thing that's really unique to Semgrep, and just to give you a sense of, oh, like why, what's the Python stuff good for? Semgrep is actually scriptable in Python. So here's an example. We can't run this on the live editor because it involves arbitrary code execution. But if you have a .semgrep.yaml file, here's an example where we're actually using pattern-aware Python to specify arbitrary code that will run on the output of Semgrep. So it'll capture whatever the metavariable that was captured inside $f is. We can put any Python code that we want here, and if it returns true, it will filter the result. So we're security paranoid people, so this requires this very long, very scary flag, dangerously allow arbitrary code execution from rules. But it's really powerful to be able to use Semgrep to kind of like get to the interesting part in your code base, and then you can have whatever other custom logic you want do the processing on that part. So there's a question in the chat about whether you can do source to sync analysis by stringing together chains. So there's actually a completely different API. I mentioned that there's a sort of core library behind Semgrep. That core library supports basic taint tracking analysis, but we haven't yet exposed the kind of like front-end configuration format to be able to use it to answer that question. So one last thing, we've been having all these examples where we kind of went through and like copied code from the source code into the pattern box, and then we edited it a little bit. Wouldn't it be cool if we could just highlight the code and say, generate suggested patterns? So believe it or not, this is actually an intern project. Our intern Emma did this. She's an incredible intern. So I will just select this line of code. We're looking for RC4 ciphers inside Golang and say generate suggested pattern. And as long as everything hasn't broken, we'll get a whole bunch of suggestions for like, okay, if I want to exactly match the key, if I want to exactly match the metavariable, if I want to have extra arguments after it, or if I want to have any number of arguments, and I could just click use. It's going to update the pattern right here. And then boom, we had just highlighted line 12 and we're automatically finding line 13 and 15 inside the code base. I saw there was a question about aliasing in Go earlier, which I'm trying to remember the syntax. I think I can just say like, if SHA is an alias for like crypto RC4, does aliasing work? And I believe this does. So even if I in Go rename this to SHA, so this is the alias for crypto RC4. So like if you were grepping for this, you would be like, oh yeah, this is totally safe. But Semgrep is still going to map through it just fine. I think I missed a question about that earlier. So what are the features that are coming in Semgrep? So more code equivalences are obviously great. The whole idea here is you should be able to write a pattern really easily, and then the engine should do the heavy lifting of figuring out, hey, what are all of the equivalent variations of that ought to match? So that's what we mean by a semantic grep. It finds all the things that are semantically equivalent. We're always working on that. It's easy to define your own now, but we still want to put more and more of them into the core engine. Being able to do better type inference is also up there. So like basic examples like this work, but inferring types across files is something that is actually not that hard to do and pretty cheap because there's so many good type checkers. Even for languages like Python and Ruby and JavaScript that didn't used to have types, people have written type checkers for them, which is super cool. This example of like, hey, I want to match a call for func with foo as the argument. This example works, but we want to do even more, like broad examples of that, where it's like, oh, I set X in earlier in the file or like in another file, making things like that work automatically just so that we can maximize the amount of things that are covered automatically. And then to the tainting question, things like, oh yeah, like, well, really I only care about that metavariable if it actually comes from some sort of source which relates to user data is super powerful as well. More languages, Ruby and TypeScript are on the top of the queue. Ruby support is actually in beta right now. So shoot a note to me via email or just support@r2c.dev if you're interested in that. And then we are really excited about the pattern from code feature, and we're planning to add a lot of support for that, so that even if you have a coworker who they're a little fuzzy on what is an AST exactly, anybody can come in, highlight some code, right click, and see if the search results for it are any good. That's pretty awesome. So yeah, in summary, I've presented about Semgrep. It's a lightweight static analysis tool for many languages. You can find out more by going to semgrep.dev. You can install it via brew or pip. If you want a really basic config that doesn't have a whole lot, but just to get started, you can run semgrep --config = r2c on your current directory. And if you wouldn't mind, we have a little survey about this presentation. So if you thought this presentation was great, it's because people in previous talks filled out the survey and gave feedback to make it even better. So I really appreciate that. Yeah, and I will go double check the stream, I guess, for any more questions, and invite Ben to join back into the presentation room.
Yeah, sure. So I think you've been answering most of them as you go along.
Yep, looks like it. I think I got them all.
Mm-hmm. Cool.
Fantastic.
Well, we can hang out for another minute or two and give people just a chance to sort of wrap their heads around it, or post any final questions. But your information's right there if they want to reach out to you for for more specific things. And yeah, again, thank you everyone for joining the channel, and for those who watch this at a future date.
Awesome. Yeah. Any questions from you, Ben? I guess I should ask.
Oh, yeah. So you said that this only works, that this only runs against a single file at a time. But can you feed it multiple files, or and that way you can kind of use it to point it at an entire repo? Yeah.
So I mean, I guess it'll run over an entire repo. Actually, it'll run in parallel. So this example 3 here with the dot, that'll scan everything inside the current directory, cool. And it'll automatically parallelize it. So it'll be in cores. Which is nice. Makes it very, very fast.
Yeah. Have you done any performance metrics on speed?
Yeah. So our goal is 100,000 lines of code per second. I've seen it be as fast as 500,000 lines of code per second, and as slow when there are bugs. If you're seeing 100 lines of code per second, that's definitely a bug. I think the lowest that we try to tolerate is 20,000 lines of code per second. Still nowhere near grep, or if you've heard of RIP-grep, which a lot of security people like to use, RIP-grep is just blazingly fast. So we're not going to catch that. But it's pretty decent for a tool that actually understands the syntax of the source code.
Right.
Yeah. One thing I'll add is that, as you play around with this, we've tried to make it really easy to report bugs. So, if you did something that was not valid Golang syntax, like this, I don't think is Golang syntax, you should get a fairly friendly error message, but you can always just click this button to report it as a bug, which will automatically create an issue with a link to the snippet, which is pretty cool. So we've had a lot of people from the community just contributing oh yeah, hey, I really think this ought to work. So don't be shy about doing that, for sure. We're pretty receptive to those sorts of bug reports.
Sure. And yeah, just one last time, that's r2c.dev/survey. And yeah, I'm sorry, there's one last question really quickly. Any plan for a Maven plugin?
Not currently, but we have a couple people who have been writing plugins and just haven't told us about it. So I guess it depends on what you're trying to do. One of the things is that the Semgrep binary is pretty small. So the Docker image is only 50 megabytes, and it's statically linked. So it's pretty easy. It's just Python and a statically linked executable. So it's pretty easy to integrate it into any kind of environment. It really shouldn't be that hard. Maybe not quite as easy as a regular GNU grep. But if you end up working on that, please join our community Slack channel and just make a note. Actually, if you ask in there, it's possible that somebody else has already done the Maven integration, and I just don't know about it.
Sure. All right. Well, I'll stop the broadcast then, and I hope you all have a good night and stay safe.
Absolutely. Well, it was a pleasure to present virtually, Ben. I hope to meet you guys someday in person. I've been in Nova. It's a lovely area when there's not coronavirus ravaging. So
take care.
All right, have a good one.